When we look at adaptive immunity, we've got some options. Everything is targeted in adaptive immunity on one specific antigen at a time. So whether or not you get that immunity actively or passively is what we're going to focus on now. So active means you're going to build antibodies. Passive means that we're actually going to give you antibodies directly. We're not going to wait for you to build them, and I'm going to show you why. Antigens, remember we said, are any foreign molecule that comes into your system, and when we look at these, we said this is invertebrates only, not in invertebrates. And this is a specific response. So this is not general. If you have a fever, that's great, but it's a general response. And we have to look at remembering or learning what is going on. This last one is going to be the most important for you long term. When we look at vaccines, so we've talked a little bit about vaccines already, but what we're doing is actually giving you a small dose of the pathogen or antigen that we're interested in. Most of the time we look at that vaccine as having what we call a harmless variant. So we've essentially taken away its infection type properties, but your body still needs to fight it because it's an antigen. We have to look at building up this active immunity, so building antibodies to that vaccine, and that's our target. We can have passive immunity if we give you pre-made antibodies. We don't wait for your system to build them, and the times when we do this are like snake bites. If you need antivenom for a snake bite, if we actually waited for you to build antibodies to the snake venom, you'd be dead. We have to give you the antivenom very, very quickly. And antivenom is simply antibodies to that particular venom. Still very specific to a venom type. When we look at lymphocytes, so these are our lymph cells, white blood cells that are in the tissues and organs of the lymph system primarily. So this would be in your lymph nodes and your spleen. And we look at them being responsible for this adaptive immunity. So we said about raising the response rate. All of them come from stem cells in your bone marrow. We're going to focus on B lymphocytes or B cells. And these are made in the bone marrow. B for bone marrow. T cells are made in the bone marrow, but develop in your thymus, which is a gland in your neck. The B cells are going to be responsible for something we call a humoral response. This humoral response makes antibodies and releases them to the blood. T cells do what we call cell-mediated response. And the cell-mediated response is a direct attack on the antigen. Now this antigen, remember, could be a bacteria, could be a virus. I don't care what it is. Okay? And what we look at is these T cells as essentially recognizing an infection and then signaling the B cells to produce a particular antibody in response. So we start in your bone marrow for either one, and the bone marrow are going to produce B cells directly. These are our antibodies. Antibodies produced. T cells start in the bone marrow, go to the thymus, and then are ready for going out and helping to defend through that cell-mediated immune response, so the direct attack. But both are going to have to work together to make sure that your adaptive immunity is correct. You notice they don't look a whole lot different, right? They both start out in your bone marrow. They both start out in the same way. But what we're looking for is you have millions at this point in your life of different B cells and T cells, each with a specific antigen receptor. So these are specific responses. That's important to keep in mind. This is not like our mast cells that don't care what the infection is. They're just going to attack everything and release fluids that make you stuffy or swollen. What we are looking for now is a very specific adaptive immune response. And when we look at an antigen that you are going to have a specific response to, we are looking for things that signal not you to your immune system. So when you're just a fetus, you spend a lot of time, your immune system spends a lot of time learning who you are. And when we do that, what we're looking for is in the future being able to say when there's an antigen, what's not part of you. Really important. We go through clonal antibody mediation. We've got to build these cells. Okay? So effector cells are special cells, or specialized, and can actually look at multiplying very, very quickly for defense. Memory cells, these are the ones that are going to be responsible for long-term immunity. So literally remembering that you had this infection before, you have antibodies for it stored, and you need to pull those out and use them quickly. Plasma cells are effector cells that are produced during B cells selection. So don't stress too much about these differences. What I want you to think about is here on the picture. These are antigens currently stored inside your body. They have color-coded them, of course, to help us with this discussion, but for you, they're not color-coded. But they are shape-specific. So we are back to the idea that 3D shape is everything, because what we're looking for is this antigen to specifically fit in an antibody. So the antibody needs to attach to the antigen. When it does, when this fits, millions of these particular antibodies will be cloned. And fight the infection. They'll target these antigens. Your non-specific responses of killer cells will come in and help destroy all of the antigens that have been targeted by the antibodies. Now, in this process, I said you make memory cells. These are going to go get stored for the next time you get the same infection. The plasma cells are the ones that are going to go out, release these antibodies to target the antigens for destruction. When we talk about immune response, the primary immune response is the first time you've seen something. First time you've been exposed to an antigen. In this way, this is going to be a fairly slow response because you have to build new antibodies that fit that antigen. If this is the second time or more that you've been exposed to an infection, you just go into your memory cells and go through clonal immunity like we just showed you. As you might guess, this secondary response is much faster because you already built the antibodies. That's more than half the battle. In our primary immune response, we have to build brand new antibodies. So the first exposure to an antigen, we have to find an antibody that's going to fit. If we don't find one, we've got to build one. So this is the idea of building new antibodies. If you've already been exposed, if you have stored memory cells, so stored antibodies, then this is much faster. You make a ton of antibodies very, very quickly. You store more of them, so we're still going to store more of these for later in case you get an infection a third time. But the idea is, with our primary response, this is the first time you're exposed, and it's slow. Secondary, it's the second time or more that you were exposed to an antigen. And this should be a faster and stronger response to the antigen. Should be. Let me show you. So here's your primary immune response. So this is the first time you've been exposed. Day on the x-axis. So you get exposed. It takes a several day incubation period before you actually know you're sick and before you start to build antibodies. Your body recognizes that there is something new and different and bad, and it takes you roughly 2 to 3 weeks to really build up, and even longer in some cases, to build up antibodies and then to store memory cells for next time. Antibody concentration on the Y shows you here for our first response. For our second response, so say you get exposed to the same pathogen 2 weeks later. Well, the hope is that you're going to have those memory cells that are going to come back out and say, hey, we know what this is, for this secondary response. And you notice this time difference here, 7 days. 7 to 12 days, a full-on response, huge response. Here, it took you nearly 20 days to start to fight this infection. And look at the difference in the amount of antibodies produced. Huge differences. Now, that's not to say that you're going to get exposed to just that antigen X again. What if you get exposed to antigen Y now? Well, now we start all over. Okay, so we've got the same deal where we've got to build antibodies to Y and then store those as memory cells. But the hope is with a secondary infection that it is faster. And as you see here, much stronger response as far as concentration of antibodies that are produced. This is what an antibody looks like. We draw them as Ys, and this is Y. They look like a Y. Okay? And what we're looking for is these B cells to release these antibodies that are going to come in and help you target the antigen. They are not going to destroy. These are not the destroyers. The destroyers are T cells. Once an antibody is attached to an antigen, the T cell finds that attachment and says, all right, it's time to die. So cytotoxic T cells actually come in and are the T cells that will kill infected cells. These are the only ones. We said that this was sort of the frontline defense. This is very strategic, very specific defense to the antigen antibody complex. So cells infected, it gets targeted by an antibody. When it's targeted by an antibody, the cytotoxic T cell comes along and actually injects enzymes that are going to eat holes in the cell, and the cell will literally explode.